your desk. It's all messed up.
Okay, so today we're going to talk about imaginary numbers.
Oh, I hate imaginary numbers. No, they're not.
I don't think you're going to hate it.
I hated it the way that my last teacher taught it.
Okay, so say you do a problem, you solve it, and your answer is square root of -5. What does that mean?
It's imaginary.
What two numbers?
But what does it mean? Like if you did that, like if you try to put it in the calculator, what would the calculator say?
I don't know.
Error. Would it not?
No.
Would it not say error?
It would say domain error is what it would say. So, or no solution, no real solution. So what we have is we have mathematicians who have created another set of numbers, and they're called imaginary numbers. And what they do is they allow us to do all sorts of things in electronics. I can't tell you how they do that because I don't have a job where it does that, but they use imaginary numbers. So it allows us to have another plane, so the x-axis, the y-axis, and then the imaginary plane is a whole other plane altogether. So it is how we, I'm told that it is how our cell phones work, which is pretty cool.
Our cell phones aren't imaginary.
So they use imaginary numbers. Yeah.
They're not.
Yes. So imaginary, this is called, so I is defined to be equal to the square root of -1. Okay? So within our number system, the real numbers, we do not have I equals square root -1, but we're talking about an imaginary number, I equals square root -1. We'll talk about complex numbers tomorrow. So what we're going to do is we're just going to simplify in this arena. So square root of -81. Could I rewrite this
Yeah, you can.
as square root -1 times square root 81?
Yeah.
Yeah. What is the square root of 81?
9.
9. So this would be the same thing as I times 9. Or we like to write it as 9i. We like to treat it like a variable. When we have a number next to it, we put the number in the front and the variable second to it. Okay, so what would we do on number 3 if we're simplifying square root -50? What would we do?
5 and 2. Probably solve for 50.
Okay, so we have 50, and then what do we do with that 50?
5.
Okay, so if we're using the factor tree, 25 and 25 and 2, right?
Yeah. And then that goes into 5 and 5.
5 and 5. So this is the square root of -1 times square root of 5 times 5 times 2. What do we do next then to simplify that?
You combine the 2 5s.
So these, and what would we do? A hand, please. What would we do with that? Well,
You combine them.
yeah. And so what do we do? Where do we move? Where do we do with
You
this?
put the 5 on the other side.
That's right. So we're going to put the 5 in the front, and this is going to become 5i, and the only thing left inside the square root is the 2. So the reason we put the I in front of the square root is if we put it to the right of the square root, we're not sure when we write it whether it's underneath the square root or outside of it. So it's so much clearer if we just write it like this, 5i times the square root. Does that make sense? Okay. So how would we simplify square root -80? JJ knows. Anybody else? Go ahead, JJ.
You solve for 80, so
Okay.
2 and 40, and then 5 and 8.
Okay, so we have square root -1. I'm going to write that separate. Times square root of 1, 2, 3, 4 2's and a 5. So somebody at that group back there. What do we do next?
We put the pairs in the square.
Good. So we have a pair here and a second pair, don't we? And so where would we move those 2's? That's right. And so it just becomes 2 times 2i square root 5 or 4i square root 5. Does that make sense?
Yeah.
What about number 5? Somebody in this group back here. Tell me what to do on number 5. And then what do we do with the 9 and the 6? Good. And so tell me what to do next back there.
All threes.
Square root negative 1. Oh, negative square root 2 times 3 times. So why did we not put a negative 1 on the inside of this one?
The negative's on the outside.
Yeah, the negative's on the outside. There's no negative on the inside. So we leave that out there. We have a pair of 3's. Those 3's move out to the front, and it is negative 3 square root 2 times 3, which is 6. Does that make sense? Okay, I'm going to skip number 6, and this is, I'm going to have you do this you try right now. On your paper, please, or on your desk.
There's no I. There's no I.
No, I because the negatives on the outside.
No, we can change
No,
this
no.
and ask for help.
No.
She's already confused. She's in the yeah, she's older than 98, bro. It's like 12 or something. 12 and 9. Oh shit, it's 98. She's so smart. What's 9? Oh, older than 98.
Oh, wait.
40 and 2.
You got 48 and 2. That's not right though. That's 8. That's 96. I thought it was 96. You're voting it. Cohen, it's 49 and then 7 7. 49 times 8. And then
49 and 2, right?
oh damn, Cohen, you're so smart, bro.
I'm serious. No, not even. You can't be talking like that, Henry. You can't.
Oh, you know what?
Okay, that's why we know you try. Okay, so you should get an answer of 7i square root 2. Any questions on that before we move on to the next one?
Nope.
I can't read your hair.
Okay, so what's different here?
The next 8.
have a number in the front. So what do we do on this one?
This one? Oh.
Number 8.
You want to divide it?
So do we want to divide this one? Why don't we want to? Who just said that? You did? Yeah, why? Oh, you didn't say anything? Yeah, why don't you want to divide it? You don't want to divide this one. Why don't you want to divide 36?
The perfect square. It's a seam.
It's already a square. So you take the square root of 36 and it's 6. You can do that. It's just going to be a lot of work. Take a look at it. And if you're not familiar with your perfect squares, try it every time first. And see if you get a number that is perfect square. So this one is 48 high. Does that make sense? I'm not giving you. I'm not giving you. No. I'm going to answer a question, but I can't hear it. Yeah. So 8 times square root negative 1 times square root 36. So that gives us 6. That gives us I, and so it's 48. Is that clear? Okay. So what do we do with number 9? Somebody in this group. Here, what do we do with number 9? I'm going to have you guys answer another one. Go ahead, Joseph. Go ahead. What do we do with that?
Turn it to 25 and 3.
Yeah.
And turn 25 and 5. Take the 5 out.
Negative 5 square root negative 1 times 5 times 5 times 3. Thank you, those of you who are sitting quietly. And then go ahead, Yusuf.
Oh, 2 5s is a pair, so you take it out.
And so negative 5 times 5. What's the square root of negative 1, Yusuf?
1. Wait.
Square root of 1 is 1.
Yeah.
Square root of negative 1 is? I, that's right. Negative 5 times 5i times square root 3, or negative 25i square root 3. Okay, we're going to do 10 last. What do we do on number 10? Back here in this group. What do we do first?
9 and 2.
So 18, we're going to take our prime factors, doing a factor tree, 9 and 2, and then 3 and 3. So this gives us negative 7 times what? Good. And then we're
on the other side.
That's right, the 3, we have a pair of 3s. So this is negative 7 times 3, square root what, Will?
2.
Yes, and so my answer is negative 21 square root. Is it an I?
No, because it is on the outside.
So no I, because, why was there somebody answer, why is there no I on this one? Right, no negative inside the square root. So that's our answer. Okay, can I get somebody to pass out the worksheet?
On your microphone.
Thank you so much. Thank you so much.